So you need just a little bit of 3 mole of HCl. As you can tell, there's not much of it. And then we have this piece of metal zinc. And as you can tell, the solution is really clear, and the metal is a metal. It's shiny, but it's very flexible. It's not very much. It's not really a hard metal. So as you see here, this is the steel wool that we will be using to scratch the zinc with. It's a hard substance, very scratchy, something you wash your dish with. And here I am scratching the metal zinc with the steel wool. I'm scratching really hard to make sure that scratches made in the steel wool really makes contact with the zinc. So I'm about to put this zinc into the solution. As I bring it closer, I drop it in. You can actually tell that, you can't really tell right now, but a lot of tiny little bubbles are being formed around the metal, on top of the water, underneath, all throughout the solution. And it's really cool to watch, like as these thousands and thousands of bubbles are formed every second surrounding the metal and the solution. So as you can see here, we have copper sulfate or CuSO4, which is very blue tinted type solution. So as you see here, I have K2CO3, and I am about to mix 10 milliliters of that into the copper sulfate. And as I do this, which it's pretty much an instant reaction once some two liquids are formed, the outcome is more of a blue chunky type substance, chunky. Anyway, the test tube seems really full, very again. As you can see, as I'm more personal with the liquid, you can tell there's like actually a solid in there. Like it went from more of a liquid to a more solid type substance. So as you see here, I have a 50 milliliter sample of hydrogen peroxide, which as you can tell is very clear. So as you can see here, Dr. Lipchuk cut up a potato with no peel. And sorry, as I'm talking, I had to re-talk because people were talking in the background. But I will drop the potato into the hydrogen peroxide, and I'll shut it with this little cap. And as you can see, a lot of tiny little bubbles are forming around the potato, on the bottom of the solution, all around the solution. And this will stay a course for most of the reaction until it reaches equilibrium, but there's just a little bit of bubbles. Not too many bubbles are formed, but it's a pretty cool reaction to do. So in this video you can see me catching this wooden split on fire, and I'll let the fire put it in the air around the potato. The theory was that the stick would relight, but Dr. Lipchuk said it wouldn't happen. She was correct, it not happened. We don't know why. It should have, but not everything works out. So sorry again, there's too much audio in the background, so I had to re-talk this. But here is this piece of copper wire, and it's very smooth. And I'm holding it with a tong, but the copper wire is very smooth and it's very flexible. So as you can see here, I have my safety goggles on, of course, because safety is the most important thing. And I will put the copper wire into the fire of which Dr. Lipchuk lit. And as you can see, when I put it in, I put the copper wire into the hottest part of the fire, which is the blue part. And as if you can zoom in, oh, you probably couldn't because it's a video, but you can slowly see a dark type blackish ash or crust forming around the metal that's inside the fire. So now observing the metal after a couple, like 30 to 45 seconds in the fire, you can tell that it's really dark around the sides and a dark crust is formed. So as the metal was put in the fire, the black crust is formed. So as you can see here, I'm trying to, not successfully until I put it down, but get rid of the black crust by scraping it off the metal. So as you can see, after we scraped the outer lashings of the metal is still shiny. So the copper was dark after the fire, but after you scraped it off, it's still shiny. And yeah.